Hello guys, Art-Teeves here. This video covers the whole process of creating my pirate crabbot statuette. I won't narrate the entire video, so I'll leave you at some point, but first I'll explain all the crucial steps. Why a statuette? Well, I didn't use any reference images, and only had a rough idea of how it should look. Its arms and legs emerged spontaneously, so I didn't build this guy in a T-pose, which of course complicates animating him later. I won't be animating this guy anytime soon. However, if I did want to animate him, I'd begin by combining the 3ds Max's biped system and separate IK rig for the third leg. First I'd set up a standard biped, stripping away any unnecessary components, then adjust the remaining two legs to match the robot's proportions. For the third leg, I'd implement either a bone-based IK chain with an HI solver or a dummy helper system. Since this guy has a really simple topology, I didn't even use my usual approach that involves combining ProBoolean tools and automated retopology. To enable full 360-degree body rotation, I split the model into two parts, the torso and the leg segment. The final model sits at 10.2k polygons and 10k vertices, a lean mid-poly count achieved through direct optimization rather than high-to-low poly baking. Key mechanical details, like chamfered edges, were modeled rather than painted, trading some poly efficiency for sharper real-time depths and, most importantly, making the process much easier. I also modeled some rubber joints manually. Since I painted a few of them, I now think I could have painted the rest as well. I began by shaping the robot's eyes and body from basic cylinders. Using the FFD modifier, I adjusted the body's initial form. Next I created two cylinders for the eye tubes, bending them and varying their height and angles slightly, before merging them to the head with ProBoolean. Finally, I manually refined the topology. The key consideration is ensuring the main cylinder has enough sides for proper shading. Mine uses around 28, which may be excessive. The eyes and eye stalks have 16 sides each. Each leg has 16 sides, which is definitely an overkill. Each hand has 10 sides. Essentially, the robot's lower section offers the greatest optimization potential. The leg poly count could be reduced by nearly half. Remember, most openings or intersecting seams between cylinders should be bordered with circular loops of nearly square polygons for better shading. Also, it may be a good idea to enlarge and exaggerate some elements like pincers and eye periscopes, so that the model retains its overall cartoony design. For optimal results with the ProBoolean tool, it's the best practice to isolate the components you plan to boolean from the main model. Only apply the modifier to properly intersecting geometry, ensuring clean overlaps. This workflow significantly reduces potential mesh artifacts and preserves your model's integrity. Also, we don't want to add some small, yet overly detailed elements. This model won't use load variance, so we're strategically employing triangles on flat, non-deforming surfaces where they don't impact shading quality. However, for any potentially animatable components, we maintain clean, near-square quads to ensure proper deformation if rigged later. If you're making some separate objects, make sure they intersect each other naturally but never share any vertices or planes. This prevents Z-fighting. Z-fighting happens when two surfaces occupy the exact same space in a 3D scene. Since the graphics card can't decide which one to show, they flicker as they fight to appear on top. When modeling rubber connectors, ensure they are elongated sufficiently to prevent metal components from clipping during articulation. Additionally, reinforce all deformable areas with adequate edge loops. This maintains clean bending topology while avoiding pinch artifacts during movement. Also make sure that the UV chucks are straightened properly, so we can actually paint horizontal strips on them. If you are modeling some rigid robotic limbs, it will be much more convenient for you to create them as separate objects, centered to their rotation points. To simplify the modeling process, I optimized the leg attachment system by breaking it into 3 identical segments. After deleting 2 sections, I refined the remaining attachment point, then duplicated and rotated it twice at 120-degree increments. This approach means we only need to model one leg and one attachment point, with the others created through duplication. The entire model uses a single 4K Reso UV atlas with 16 pixel padding, a more efficient solution than separate maps. UV seams follow hard edges, and islands were straightened in Rizom UV for minimal distortion. There are no overlapping UVs here. Actually, a 2K map with a padding of 8 would be more than enough for a model of this complexity. As in my other videos, I have created a 4K map primarily for demo purposes. Texturing this character relies on modified smart materials with steel, worn metal and rubber presets forming the base. Since we are dealing with a pirate robot, the palette leans into scratched, weathered metals and rusty dirt gradient for a rugged look. I've also relied on blur slope filters to give my paint a more stylized, cartoony look. This model skips baking high poly version to a low poly one entirely. Details come from modeled geometry. The stylized approach allows some liberties, but most importantly, makes the whole pipeline so much easier. I fix most smoothing groups between modeling and unwrapping. This way I can simply place my UV seams on existing hard edges. I also use the 3ds Max's X-View tool to scan my model for some overlapping or isolated vertices and open edges. Then I select all polygons that have more than 4 vertices and convert them to quads or trees depending on their locations. This covers everything I wanted to mention. I'll stop narrating at this point. Thanks for watching, guys. If my videos are of use to you, be my guest and subscribe to my channel for more stylized content. And most importantly, have a great day.